When converting between rectangular and polar coordinates, it might be helpful to memorize a few relationships between them. So for instance, when a polar coordinate is written as r theta and a rectangular coordinate written as xy, if they're the same point, then r squared equals x squared plus y squared, and tangent theta equals y over x. Furthermore, we know that x equals r cosine theta and y equals r sine theta. Now, since all of these coordinates that we're given right here are in polar form, we want to convert from polar to rectangular, and that's these two equations right here are most helpful. Now, let's take part C for instance here. We have the square root of 3, negative 3 pi over 4. And this square root of 3 then is our r. This negative 3 pi over 4 is our theta. That means we can just use these formulas straight away. X is equal to the square root of 3 cosine of negative 3 pi over 4. And y is equal to the square root of 3 sine of negative 3 pi over 4. Well, what are the sine and cosine of negative 3 pi over 4? And to find that out, we can draw a unit circle, and instead of going counterclockwise 3 pi over 4, we go clockwise, which brings us here, halfway between pi over pi and 3 pi over 2, which is 5 pi over 4. 5 pi over 4 actually have the exact same cosine and sine value, and that is the square root of 2 over 2. All right. What we have next then is to just fill in the blanks. So here, I can see that since the cosine and sine value are the same, both of these are going to equal the square root of 3 times, this should be a negative square root of 2 over 2 because we're in the third quadrant. So we have negative square root of 2 over 2. And we can simplify this to simply negative square root of 6 over 2. Notice that when you're multiplying square roots, you can multiply their contents. That gives us the point then of negative square root of 6 over 2, negative square root of 6 over 2.